Good morning Year 4 and welcome to Thursday's maths lesson. Here are the answers to yesterday's questions. If in a second you can pause the video and check your answers, and as usual, if there are any problems, any questions you have regarding this, please put them onto Purple Mash and I'll get back to you, or one of the teachers will. And we'll just quickly go through what was needed in these questions. So in the first one, we did quite a lot of work in the lesson yesterday about checking the scales to make sure that you knew what each of the bigger lines and then the smaller sections stood for. Hopefully you realised that they were all different and you were able to work out the mass of each of these items. And then we had quite a few questions where you were converting between kilograms and grams. We had to convert that weight into grams, and then you were given a weight in grams that you then had to convert into kilograms and grams. It was really important that you remembered that 1 kilogram is the same as 1,000 grams. And if you kept that in mind and you were able to partition these amounts appropriately, that would really help you. So if we look at this question, 8 kilograms, 689 grams, we need to convert that into grams. So I know that 1 kilogram is the same as 1,000 grams. So 8 kilograms is going to equal 8,000 grams. And we have 689 grams that are already in grams. So we add that onto the 8,000 and our answer is 8,689. And then when we're looking at a mass that's already in grams, 4,900, I know that 1,000 grams is the same as 1 kilogram. So 4,000 grams will be the same as 4 kilograms. We've got 900 grams left over because that's not enough to make a kilogram. So we need to add that back onto the 4 kilograms. And the answer is 4 kilograms, 900 grams. So hopefully you were able to do those okay. And then we had some more examples where we were doing those conversions. And then in this question, we were matching the equivalent weights. So 3,230 grams, you needed to match that up with a bag on the other side, which weighed the same amount, but was written in kilograms and grams. So pause the video, check those. So on to today's lesson. Today we are learning to understand litres and millilitres. So again, it's another unit of measure. And again, we did cover some of this in Year 3. So hopefully this will seem a bit familiar to you. And we'll go through a sort of refresher today. So first of all, it's important that we remember that 1 litre is the same as 1,000 millilitres. So you can see it written here, 1L, which we read as 1 litre, is the same amount as 1,000 millilitres. And we use these measurements to measure volume and capacity. So we're going to look at this picture first of all. How much water can this bottle hold? We're pouring the water from this bottle into this jug so that we can measure that volume. And hopefully you can read this scale on the jug, but you can see that there is a scale here. At the top of it, it reads 1 litre. So we know that this water which has been poured into the jug to measure it, the volume of water in the bottle is 1 litre. And we therefore know that the bottle can hold up to 1 litre of water. So the capacity of the bottle is 1 litre, sorry. We'll speak about capacity and volume in just a second. So if we have a look at this flask here, we can get a really good idea of the scale. And much like yesterday, we need to pay careful attention to what's at the top of the scale and the smaller measurements as well. We know we've got 1 litre at the top, which is the same as 1,000 millilitres. And then there are 10 bigger sections, markings on the scale on the way up. We divide that by 10 and we know therefore that each of these represents 100 millilitres. 100, 200, 300, all the way up to 1,000, which is written as 1 litre because 1,000 millilitres equals 1 litre. We also have much smaller markings here, And again, there are 10 of them up to 100. So I know that each of these smaller ones is 10 millilitres. So volume and capacity are measured in litres and millilitres. And we have the smaller measurement of millilitres, and then once we reach 1000 millilitres, we have a litre. So again, we're looking at a flask over here. The liquid from the flask has been poured into 2 measuring jugs so that we can measure the volume of water that's in that flask. If you look at the scale here, we can see this jug has 1 litre of water, so 1000 millilitres, and this jug has 400 millilitres of water. We add the 2 amounts together, 1000 millilitres plus 400 millilitres, which is 1400 millilitres. And we know that 1 litre equals 1000 millilitres, so we can also write that as 1 litre 400 millilitres. Now you'll notice here that it says the flask has a capacity of 1 litre 400 millilitres. And we're just going to go through what capacity means over the page. So we've used the words volume and capacity so far in this lesson, and they are different. So how is volume different from capacity? Well, the amount of water in a container is called the volume of water. So if we look at container A, first of all, it's partly filled with water. And we're being told that there is 800 millilitres of water in that container at the moment. So the volume of water in the container is 800 millilitres. If we fill the water up to the brim, so that it's completely full, and then empty it into 2 measuring jugs, we then see that the volume of water that we have in these jugs is 1 litre 200 millilitres. That also tells us that the capacity of the container is 1 litre 200 millilitres. The capacity of a container is the full amount of water it can hold. So if we go back to looking at the container here, the capacity of this container is still 1 litre 200 millilitres. Even if it was empty, the capacity of the container is 1 litre 200 millilitres. That's because it's the full amount that it could actually hold if we wanted to fill it up. At the moment, even though the capacity of the container is 1 litre 200 millilitres, the volume of water that's actually in this container is still 800 millilitres. So that might be blowing your minds, or you might have got that straight away. If you want to pause the video or rewind it and just listen to this again, this is a really good explanation. So you might want to pause the video and just read it again in your own time. Read it out loud in your own voice to help you understand it. Please do that, because it's important that we understand the difference between capacity and volume. So please pause that if you're not sure, rewind the video and listen to that again. Let's have a look at this question. Ella has some measuring jugs. Each measuring jug has different markings. How much water does one small marking stand for in each measuring jug? So this is similar to what we were doing yesterday, where we had to really pay attention to the scale on the weighing balances yesterday. Today it's on these jugs. So I hope you can see this, but we have a scale that goes up the side of the jug and it reaches 1 litre at the top. Now we know that 1 litre is the same as 1000 millilitres. So I can see that there are 10 markings, so I know that each one of these therefore represents 100 millilitres, and that there is 700 millilitres of water in jug A. I hope you can read these. It's not particularly clear, but I can tell you that jug B has 100, 200, 300, 400 millilitres of water, and that each of the small markings stands for 50 millilitres, because we've got 50, 100, 150, 200. So there are smaller markings yet again in between each 100. And then on this jug, it goes up to 100 millilitres. Halfway up is 50 millilitres. So this is a smaller jug again, and each of these individual smaller markings therefore stand for 10 millilitres. So this shows the importance of just paying attention to the scales on the side of the jugs. So I'd like you to pause the video in a second and have a go at finding the total volume of water in each set of measuring jugs. So you'll need to pay attention to the scales on each jug, work out the volume of water that's in each of these jugs and then add them together. And then I'd also like you to have a go at question 6. Each tank is completely filled with water. The water in the tank is emptied into some measuring jugs. So you need to find the capacity of each tank. So just going back to that earlier discussion that we had, these tanks are full. So that tells us that the volume of water that is in these tanks is going to represent the capacity, because remember, the capacity is the full amount that a container can hold. And these arrows show that that water is being poured into the jug so that we can measure it. So pause the video, have a go at those questions, and then we'll go through the answers in a second. So here we are, the total volume of water in each of the set of measuring jugs. Hopefully you were able to read the scales on each set of those jugs, and you could see that this jug had 500 millilitres, this jug had 100 millilitres, and this jug had 40 millilitres. So that adds up to 640. And then again, if you were able to do that for each of those and add all the volumes together. So check your answers, purple polish them if you need to. So here we're going to do some questions where we're going to convert the volumes from litres and millilitres into millilitres and vice versa. So much like we did yesterday when we were looking at mass and we were converting between kilograms and grams, and then the day before when we were converting between metres and kilometres. And it's the same, it's helpful. We know that 1 litre is the same as 1,000 millilitres. We know that 1,000 millilitres is the same as 1 litre. So the volume of orange juice in a container is 2 litres, 370 millilitres. What is the volume of orange juice in the container in millilitres? So we're going to partition that, 2 litres, because we know that we can convert litres into millilitres. We already have 370 millilitres, so we partition that and we change 2 litres into 2,000 millilitres. We add that back onto the 370 millilitres, so I know that 2 litres, 370 millilitres is the same as 2,370 millilitres. So what I'd like you to do is have a read through the questions, pause the video, and then have a go at converting these amounts from litres and millilitres into millilitres and vice versa. Pause the video and then we'll show you the answers in a second. So hopefully you were able to do these okay. It really is the similar stages that we went through in the last couple of days. We are obviously using a different measurement, a different unit of measurement rather, but it's still with that premise that we know that 1 litre equals 1,000 millilitres, and we're partitioning it in much the same way. So hopefully all your work this week has helped you work out these. Check your answers, and if you are not sure about anything, please put it onto Purple Mash. I would say these look like ones. They are L's for litre. So that reads 4 litres, 928 millilitres, 7 litres, 90 millilitres, and 9 litres, 8 millilitres, not 918 millilitres. I do apologise for that, but just to clarify that. So here are the questions for today. You've got a few different containers with different volumes of water or liquid in each, and you have to work out what they would hold. So this represents the container that's been poured in, and you need to work out the volume in this jug. So each of these is the same. You don't have to worry about these. They don't have any scales on them, but they have been poured into these jugs. So you're working the volume of liquid that they held. And then you've got some word problems there to work out, and some converting of millilitres and litres. and the same on this one. So have a go at those and pause the video. I'll show you the answers in a second and then we'll go through them tomorrow. Good luck.